Hey guys, this is your study guide for Algebra 2. I'm going to do the odd problems. Those are the only ones I'm going to require you guys to turn in on Thursday. However, I've included some even problems for you guys to get some extra practice with. Actually, you know what? I think I'm going to assign you guys to do the even problems, and I'll do the even problems as well. And I'll leave the odd problems as extra practices for you. And you have the answer. Sorry, I think I got cut off there. The odd ones you guys can do for extra practice if you want. You will have the answers to see if you did them right. And feel free to remind me if you guys got any questions. Here we go. Let's begin. So the first few problems that we're doing are like what we did in class. So just today. So here we go. We have an equation here, and the equation has a polynomial, and when you have that, the first thing you want to do is you want to factor your denominators. So the first two denominators do not factor. They stay exactly the same, but I do want to definitely encourage you to be putting your binomials and trinomials in parentheses. However, on this last fraction, the denominator does factor using the box method. It's a three-termed polynomial, so to factor those we use the box. Okay, so I'm getting x plus 6 and x plus 6. Okay, the next thing we're going to do is we multiply everything by the denominators. So we'll start off with an x plus 6 here. So on this one, we can cancel those out, and we'll be left with 1. On this one, these cancel out, and that will leave us with 2. On the next one, this one will cancel out one of the x plus 6's, leaving us with this. So we still have a denominator to deal with here. And remember, keep those binomials in parentheses. All right, then we get to repeat the process again. So now I want to get rid of this other denominator of x plus 6. So once again, I'm going to multiply everything by x plus 6. Squishing it in there. All right. Now over here, these cancel out and leaves us with, let me erase some stuff here. I got to make some space for myself. All right. So now over here we have to distribute the 1. That's going to give me x plus 6. Then we're going to distribute this negative 2. Notice that's a negative because of that minus there. So when I distribute a negative 2, it's going to become minus 2x minus 12. And then on this side, all that we're left with is the x minus 1. Okay? So at this point, we just get to solve the equation. We'll put our x's together here. X take away 2x is negative 1x. 6 take away 12 is negative 6. And anytime you have an equation with an x on both sides, what you can do is just cancel one of the x's off of one side by, in this case, adding it. But whatever you do to one side, you have to do to the other. So we have a negative 6 left here. 1 and 1 make 2x. And from there, you guys will probably be pretty good. Negative 5 halves. Once again, you want to make sure that that number would not make any of your denominators equal 0. It won't. So we're good. The only thing that x can't be is a negative 6. If x were a negative 6, that would make the denominators become 0, which is not allowed. So our answer is a good answer. Okay? So let's go ahead and continue the process here. So this one I'm going to leave for you guys to practice if you want to, but I'll do this one. Here we go. So once again, we're going to start by factoring those denominators. Now the first one here, nothing factors. On the second one, nothing factors. But on this third one, we can factor this denominator. There's a GCF present there. I can divide both of those numbers by r squared. So if I divide r squared out of both of those, I would be left with r plus 3. Now we're ready to go ahead and start multiplying to get rid of denominators here. Oh yes, and let's not forget, we do want to keep our binomials in parentheses. Alright, so I'm going to multiply by r squared. I'll put it here. So in the first one, these cancel, leaving me with r plus 5. On the next one, nothing cancels. So we're going to actually just multiply these. R squared times 1 is r squared, and the denominator stays the same. On the next one, the r squareds cancel, and I'm left with 5 over r plus 3. Once again, make sure your binomials are in parentheses. And let's go on to the next part. The next part, we're going to multiply by the last denominator, which is r plus 3. So for the first one, we're just going to leave this the same for now. We'll come back to that in a second. But for the other ones over here, the r plus 3's cancel out. Leave me with that. Okay, so now here's where things get a little bit interesting. We're going to have to multiply this out using the box method. I'm going to rewrite my problem up here just so it flows a little bit better. So for this, we're going to do the box method, like I said. To multiply, we're going to put the r plus 3 on the top, r plus 5 on the side, and then we're going to multiply to fill in our box. R times r is r squared, r times 3 is 3r, and so on. Okay, so we have r squared plus 3r plus 5r plus 15 equals everything else that is just hanging out still, nothing different. Just bring it down. Okay, let's continue. On this one, we're going to start combining our like terms together. 3r and 5r can come together to make 8r. Next, we have r squareds here on both sides. So I'm going to take an r squared off this side, and whatever you do to one side, you do to the other. Now in this case, the r squared just happens to cancel on both sides. That's actually pretty convenient. So just as a heads up, if it ever happens that you still have an r squared, you have to do it like we did our example in class today, where you set it equal to 0 and you'll factor it to solve. But in this case, it's a little bit simpler. Just go ahead and solve it like you normally would. Now you do need to reduce. So 4 goes into both of those. 4 goes into the top 5 times and into the bottom twice. So there's our final answer. Okay, so there it is. Let's go ahead and continue forward. So there's one for you guys to do. So that ends our first section of the test, which is where you're going to be solving equations. And that's what we've been learning in the past 2 days of class in lessons 7.8 and 9. Now we're going back to our earlier lessons where we're adding and subtracting rational expressions. When it comes to adding and subtracting rational expressions, they need a common denominator. Okay. Now in this case, they already have one. I'll make a note here. Now in this case, they already have a common denominator. So when that happens, you're ready to combine them. So once again, I like parentheses around my binomials there. But in this case, what we're going to do is we're going to have 2n minus 1 minus n plus 4 all over the common denominator of 6n squared minus 24n. Okay? So that's the first step. In this case, since they already had a common denominator, you go ahead and just put the two numerators together in one fraction. Now in this case, since it's minus, we are going to distribute the negative. Now if it's a plus, you don't need to do that obviously, but with subtraction you do need to distribute the negative. Okay? After that, you're going to go ahead and combine your like terms. 2n take away n is n. Negative 1 take away 4 is negative 5. Now, at this point, I would encourage you to stop and see if on your multiple choice test if that answer is available. If it is, just bubble it in and you're done. If you don't see your answer, but you felt pretty confident that you did it right, maybe you need to reduce it. Sometimes it's possible to factor and cancel to reduce it a little bit. Okay? But in this case, we're good. So let's go ahead and move on. That one, even if I factored it, nothing would have happened. Let's go ahead and take a look at number 8. So for number 8, same thing. We're combining two fractions. We need a common denominator. Now in this case, we do not have a common denominator, so we're going to have to make one. Okay? Spread this out a little bit. Now, first of all, let's start with the numbers here a little bit. On this side, we have a 6, and on this side, we have a 3. So what would I multiply by, and on which side would I multiply in order to get the denominators to be the same? Well, hopefully you guys are thinking, well, if I multiply this side by 2, then that becomes a 6, just like on the other side. That would be the first thing. Whatever you do to the bottom, then you have to do the top, so I'm going to put times 2 on the top as well. Okay? Now, what about over here on this side? This side needs something as well. The 6, it needs an x and a y squared. So I'm going to put a x and a y squared next to it. But once again, whatever you do on the bottom, you need to do on the top. Okay? So let's go ahead and see what we have left now as a result. We have 5xy squared over 6xy squared minus 8. 2 times 4 is 8. And then 2 times 3 is 6xy squared. Now I've got a common denominator, and now the rest of the problem is a lot like what we did with the first one that I did a second ago, where basically we're just going to put the numerators together under a common denominator. In this case, once again, I would check at this point and see if your answer is there. If it's not, maybe you can factor and reduce. In this case, I can't factor at all, so therefore I'm not going to be able to reduce either. But just keeping that idea fresh in your head, usually you're not going to end up reducing, but it can happen. All right, let's go ahead and take a look at another one here. Let's go ahead and take a look at 10. So we have another situation where we're being asked to add or subtract two rational expressions with an uncommon denominator. Now, usually you'll need to factor first. So, do we need to factor these? Well, the answer is no, these can't be factored. But technically, anytime you have polynomials in the denominator, you should be factoring first. Okay, so in this case, we need these to look the same. So what are we going to do? Well, on this side, I'm going to multiply this side by n minus 2, because this side has an n minus 2, right? And whatever you do to the bottom, of course, you're going to do to the top. And how about on the other side over here? Well, on this side, we need an n plus 3, because this side has an n plus 3. And whatever you do to the bottom, you do to the top. Okay? So now they both have an n plus 3, and they both have an n minus 2. So let's go ahead and simplify now. You're going to distribute in, and you're going to get 6n plus 18. On the bottom, we're going to have n plus 3 and n minus 2. We'll go ahead and distribute this in as well. We're going to get 6n squared minus 12n. So now we've got our common denominator. And now we're good to go ahead and combine those numerators together. Once again, we have a minus here in the middle, so we're going to distribute that in to the second set of parentheses there. After you do your distribution, you really don't need the parentheses anymore. The distribution of the negative anyway. Notice that 12 is going to become a plus now because we put the negative inside of there. Changes the signs. And we're just going to go ahead and combine like terms. So the 6n and the 12n can go together. The 18 has nothing to combine with. And then the negative 6n has nothing to combine with. And once again, at this point, I would stop and see if my answer was there in the multiple choice. If it wasn't, then I would factor. Let's see what happens here, because this one I'm not sure if it reduces or not. It may or it may not. Like I said, they usually don't. But let's see what the answer actually is here real quick. This is how it would be written on the test. So it's exactly what I have. I was wondering if maybe they would rearrange these numbers, putting the squared first and the 18n next and the 18 last. But they didn't. So the order doesn't matter so long as the signs in front of those numbers is the same. So there's that one. Continuing forward. 11 and 12. Okay. We get to combine more fractions. So on this one, before we start combining, we do want to factor the denominators. In this case, unlike the last problem, we actually can factor the denominator. Here, they have a greatest common factor of 4n squared. So if I take out that 4n squared, that's what I have. All right. So let's start matching up the denominators then. So on the right side, we need to have two things. We need to have a 4n squared, and we also need to have an n plus 2. We need two things over there. And remember, whatever you do to the bottom, you do to the top also. On the right side, it's missing the n plus 1, so we need an n plus 1. Okay? All right, well, let's go ahead and start simplifying this a little bit. First of all, I'm going to put the 4n squared times the 6 together, the two monomials, 24n squared. over here, we've got some work to do, but we'll get to that in a second. I'm just going to rewrite it. Okay, so for the one over here on the left, we need to distribute in the 24n squared. So let's do that. If I distribute that into the parentheses there, I would end up with 24n cubed plus 48n squared. Now on the other side, this one, we're going to have to do the box method. Okay? I'm going to make some space here for the box. So I'm going to do this one separately. We're going to do the box here. It's going to be n plus 4 and n plus 1. Okay, so we have n squared plus 4n plus 1n plus 4. Those four things. And if you want to combine the like terms before you write it, you can. But okay, so now that we have that, we don't really need to do any distribution here because my middle sign here is a plus, so we don't really need parentheses now. So I'm just going to go ahead and put all this together as one giant fraction. Okay, and then we're going to combine our like terms. So I've got two squared terms. I can put those together. And I also have two n terms, and I'll put those together. And that should pretty much finish us up. Forgot my square up there. Okay, so there we go. Now, once again, they may have that answer available or they may not, so it just kind of depends. If I don't see my answer there, then I would think maybe I need to reduce. Let's see what the answer is. There it is. All right, so we don't need to reduce. So you don't want to end up reducing unless you have to, because that's more work, and as you guys can see, these problems already take long enough. So, all right, now we get to do complex fractions. That's another thing you'll see, but I'll leave the odd one for you. Let's go ahead and do number 14 here. All right, so when you're doing complex fractions, we want to find either in the numerator or denominator, anywhere where you have two fractions, we want to combine those. So what I'm going to do is I want to combine those two fractions together, and to be able to do that, I need to multiply this side over here by a 2. That way it becomes a 4. And then I need to multiply this side by a u, so it has a u like the other side. So let's go ahead and see what we have now. That would give me u squared over 9 over So now I've got my common denominator, and I can go ahead and put those together now into one fraction. 9u minus 18. Okay. After you do that, you're ready to move on to the next step, which is to change this into a division problem. So you do the top fraction divided by the bottom After that, you're going to do same change flip or keep change flip. Before you go any further, you might want to see if you could cross-reduce anything. The 9 doesn't reduce with the u squared or with the 4u. And this thing over here, we could factor out a 9, but even if we did, it's not going to reduce with anything on the top. So I'm going to skip that step. And so in this case, what we do is we just multiply straight across them. So for the top, it's going to be 4u cubed. And on the bottom, they're probably going to distribute the 9 into both of those. That would be my guess. 81u minus 90 plus 72 would be 162. Okay, there you go. Once again, I want to see how they're writing their answer. Because they may not have just decided to multiply the 9 into both of these. They might have just, instead left it outside as a distribution problem. Let's see. Nope, but they multiplied it in, so we're good. All right. Continuing onwards. I'm hoping this is the last question. Let's see. How many questions did I torture you kids with? Oh, there's more. Joy for joy. All right. We're getting there, though. Okay, so this is the same kind of thing. It's just, another one. This time, though, it has binomials in it, so let's see how this one works out. Ew, this one's going to be fun. Okay, so binomials go in parentheses, right? So on the top part here, we want to combine these together into one fraction. So in order to do that, I'm going to multiply this side by a plus 3, top and bottom. And on this side, I'm going to do a. So let's see what we have now as a result. 9 times a. It's kind of unfortunate they're using 9 and a because they look so similar. Here, we get to do the box multiplication again. So I'm going to do that over here on the side really quick. I guess we don't really need parentheses when we do the box. Okay, so I end up with a squared plus 3a and 3a come together to make 6a, and then 9. So I got these two fractions to come together as one. Okay, now we're going to go ahead and combine like terms. Or not combine like terms, but we're going to put the two fractions together. So the 9a is going to combine with this one. 9a and 6a makes 15a. So we have a squared plus 15a plus 9 over that common denominator there. Okay. Next, we change it to a division problem. Top fraction divided by bottom fraction. Okay. Then we do same change flip. In this case, these a's can cancel out. This thing here doesn't factor, so I know it's not going to cancel anything here. So I'm pretty sure what we're going to have as our final answer then. We'll just be putting those two fractions together. So clean up some space here for myself. All right, so we have just this on the top now because there's nothing on the other fraction. And on the bottom, we're going to have 2 of these a plus 3s. I doubt they're going to multiply those together. Let's see. Oh, they did. So if you actually did the box method and multiplied these together, you would get this. I'm going to go ahead and skip that, but you can do it. Okay. All right, 17 and 18. This one's just asking us to simplify. Oh, we don't really need to simplify it. I'm going to cross that off. On your test, all I want you to do is state the excluded values. The excluded values are whatever makes the denominator equal 0. So what we do is we say, okay, well, b squared minus 25 cannot equal 0. Right? And then what we do is we factor it. Now, how do you factor that? This is a difference of squares, so it's going to be b plus 5 and b minus 5. You set them both equal to 0 with a slash. We're putting the slash because it's not allowed to equal that value. And then we solve. And if you guys don't like the slash, you don't have to use it. The point is the answer is negative 5 and positive 5. Those are the excluded values. More equations. Okay, I think we're getting close to the end though. All right, so here we go. Now, we've done equations earlier today. It was our first ones that we did, but this time they're not polynomials, they're monomials. When that happens, you don't have to factor. You can just start multiplying right away. So I'm going to multiply everything by 2. So here you get 6. Here they cancel. Here nothing cancels, so I'm going to go ahead and distribute that in. Next we want to get rid of the b's, so now I'm going to multiply everything by b. Here they cancel. Here they cancel. And here we have 6b. All right. I'm going to go ahead and put the b's together now. So I'm going to subtract the 8b on this side and this side. That leaves me with negative 2b. 3 minus 8 is 5, or negative 5 anyway. And then we divide. And when you have two negatives, it's just going to be a positive because the negatives cancel each other out. So 5/2 is our answer for that one. All right, and that go ahead and takes us to the end there. So hope that was helpful. We'll see you guys in class on Thursday.